Hello, YouTubers. This channel is all about RV living, traveling, and do-it-yourself projects. Please hit the subscribe button below.
Hello everybody, thanks for joining me. I am creating a new playlist with solar as the main topic. Since we designed and built the storage in the previous series, we are one step into the design of a successful solar system. We are all addicted to electrical power, and it may scare you as much as I to wake up one day without no power and no fuel to refuel our generator. The most comical thing I hear from people that have a solar system say is, I get free electricity. This tells me that they don't do math too well. Since I pay 11 cents per kilowatt hour, there is no way I can build a solar system and produce power cheaper than 11 cents per kilowatt hour. If you look at all the solar systems installed today, 90% of them are installed with a very low storage capacity because the storage costs as much as 50% of the total system. So the salesmen have got creative and they have sold people systems, grid tie systems, that use the power company for storage. Well, the numbers just don't add up. And until we can get the storage costs down, then we may be able to produce power at a reasonable rate compared to the solar companies. But there are reasons to build an off-grid power system. If you have a place out in the country, a deer lease, a deer cabin, and you need power, that's a situation where you'd want a off-grid system. With that said, there are reasons to have the off-grid system. They make great emergency power, especially when no fuel for a generator is available. The one time an off-grid system can be cheaper than buying from a power company is when you have a situation where you need power and there's no power available at that location. It can cost as much as $50,000 to have poles set to bring power to your property. And it can cost another $1,000 to $10,000 to have poles set on your property to bring the power to your dwelling. So in those cases, you could justify an off-grid system. The first consideration to help decide equipment is what voltage you're going to use. Even though 48 volt equipment is much more expensive, in the long run, it will cost you much less. So let's take a look at how we're going to design this system. Here I've got a simple Excel spreadsheet, and I've defined some of these columns, and I'll explain to you how I've done that. This first column is the same procedure we used when designing our battery. The most important thing to note in any system is how much power you're going to use. Now, if you're building an off-grid system for a home, and most homes use 30 kilowatts per day, but you don't have the money to build the whole system at once, you need to design the system for the power that you're eventually going to create, then scale back using the same equipment that you would have purchased for the larger system. All systems that are efficient and are going to work, and this is where most people make the mistake, is they don't have the storage system large enough. For the system to be most efficient, I found that 3 days of storage is necessary. You can build storage 5 times your daily usage, but once you get over 5 times, it gets very inefficient economically. another variable that you need to research is your average sunlight hours per day. You can do it a lot of different ways, but what I have found, and I've designed several systems that are very efficient and work very well, I've always used 5 hours per day as my number here. But feel free, if you search and it says your average sunlight hours per day is 3.5, well, you can put 3.5 here. But again, I've designed a system in many places. The only time that this 5 won't work is if you're in an area like Seattle, Washington, where you got many rain days and complete cloud cover days. Then this number here should be reduced dramatically to about 2.5 hours per day. But if you've got normal rainfall levels and things of that nature, 5 is a good working number here. Now, needed power generated is very simple. It just takes column A, multiplies it times 1.4, and we're considering 40% extra is for days that you don't get the sun power, you need to replace the power that you use, and also for the inefficiencies in the system. I normally use 25% inefficiency, but to be sure that you're building the system properly, I would recommend using 1.4 or 40% more than your daily usage. Now, panel size is all up to the individual putting the system in. However, it is critical for this system to be efficient that you use all the same panels. How many YouTube videos are out there where they'll show you one set of panels put in one time and then a different brand and totally different make of panels put in on another system? You can make that work, but if you settle on a panel that meets all your requirements, I would always say you only purchased half of what you need or a quarter of what you need today and you're going to expand. You want to use the same panels. It makes the system so much more efficient and easier to configure. So one thing to note about panels, the 70 cell panels typically go up to 250, 285 watts, and your larger panels will go up to around, I think right now around 400 watts. Cost efficiency wise, it seems like the 350 watt is the most cost effective panel to purchase. It is a high voltage panel, and the next video I am going to dedicate to solar panels and explaining everything about a solar panel, because clearly the salespeople that are selling these do not get in enough detail about the panels. And the panels are what's generating your power, and just as important as the storage or the controller or the inverter. A lot of people will pick out the controller and inverter. I highly recommend you select the panel and the size of the panel. Then this column will determine how many panels. This column takes your power generator, D4, and divides it by the number of hours in a day, and then takes that number and divides by your panel size, and it will determine the number of panels you need. Well, you'll see when we start looking at the charge controller, we may need to increase the number of panels or decrease the panels to fit the charge controller that we're going to use. And everything is dependent on this first column here. So if I was designing a system that provided me 20 kilowatts a day, a system that produced me 20 kilowatts a day, I would need a 60 kilowatt storage, and I would need 16 panels. If you take a look at a lot of the videos online that's doing solar, and you go to a salesman, you'll find that they're way overbuilt here because this is where they make their money. And they're scared to show you what you really need in your storage because this costs so much money. So when you do panels, you have to treat a panel like a battery. It's only a one-way battery. It has a positive and a negative lead, and it's putting out a certain voltage and a certain amperage. And your charge controller will have maximum voltage inputs and maximum amperage input. So you'll put these in series and in parallel in order to meet your charge controller's requirements. So before you even think about a charge controller, you need an idea. Now this is an estimate. This 16 is an estimate. We may find that we need to add one more panel, or we may need to take away a panel. But since we designed the panels 40% more than what we need, we should have enough playroom here to design the system properly. So I was going to give you a visual aspect of what we're talking about as far as upgradable systems. If you know where you're going and you plan your trip to get there, you don't have to replace items that you purchased in your system. So if you know you're going to eventually have a 60 kilowatt system or whatever, you find the equipment that will handle that. And then when you're piecemealing it in the beginning, because your budget can allow you to purchase everything at once, well, then you use that equipment. In this example on the top left is the system I have. And most chargers and inverters will work in either the 24 volt or 48 volt scheme. And the top left again is a 7S, so it's a 24 volt with the same charger and inverter that you would use when you upgrade your storage system by double. You use the same inverter and charger. And then when you make the next upgrade, you have a choice. You can add another 10 kilowatts in parallel with the one on the top right, or usually when you get to 10 to 20 kilowatt storage, you may want 220 service. So in that case, you would purchase another inverter and charge controller and separate the two batteries supplying the two inverters. Now you would have to purchase inverters and charge controllers that are networkable, that talk to each other. Then when you double your system again, all you have to do is add the storage. And you can add up to 3 banks in parallel for each of the inverters and chargers normally. That's typically what I see, but there are reasons to increase the number of inverters or the charge controllers depending on the number of panels that you have and the power out that you need. So that gets us started with the solar. The next video, we're going to go in detail about the panel and how to pick out the panel, and most importantly, how to configure the panels. So until next time, check you later.